Hi and good day everyone. My name is Lishalini Murugan, matrix number DE210059. We are from Group 2 Numerical Method. Today we are going to present our group project. So these are my team members, Nur Farah Liana, Nurin Izati, Nurul Farah Ain, and also myself Lishalani. So first of all, I would like to start my presentation with the introduction part. The problem statement for this project explains why we chose this topic for our project. So, since we all know the evolution of industry in the earliest of 20s contributed a massive impact toward the climate change in this world, this climate change negatively impacting the living things and living human and also animals in this planet. So, we chose a study that is related to the energy sustainability in Malaysia. The chosen data referring to the annual power generation from commissioned renewable energy installation under FIT program in Malaysia from the year 2012 until 2018. The purpose of us choosing this topic for our project is to find the root of the problem by collecting the data of annual power generation with the implementation of renewable sources. The introduction part is followed by the problem statement. The first one is unavailability of data value for the respective input needed for the conducted study. The second one is lack of supporting data in the table of result to be used to conduct deeper research. And the third one is lack of mathematical understanding in choosing the correct method to calculate the desired output value. By relating this problem statement, we came up with the objective of the project, which is to determine the most suitable method to solve a particular problem based on numerical methods knowledge. To apply numerical method knowledge in approximating any reading for a continuous data, as in this project, the continuous data is from 2012 until 2018. And the third objective is to compare the approximation obtained from the manual calculation with the software calculation. The next one is the methodology of this project. So this is the methodology. First, start, and the next one is determine the problem of the project, define the problem objective as I mentioned and explained before. And the next step is to determine the mathematical method to be used. So in this project, the mathematical method we chose are the Lanrage and also Newton divided rule. And the third one is design the mathematical equation to be used inside the software. The software we use for this project is Maple. And solve the problem with the chosen method manually, and we obtain the value manually. And the next one is compare the result of calculation. This comparison is in between the manual calculation and also the software calculation. And the next step is report completion, then end. That's all from me. Thank you.
My name is Norfara Liana binti Samburi. My metric number DE210111 and I from section 1. I will explain about the manual calculation. Questions. Power generation install renewable energy projects that have been commissioned under the FIT program from 2012 until 2018. Biogas is a sustainable fuel that is created when microorganisms decompose organic matter such as food or animal waste in the absence of oxygen. Table 1.1 shows the data about biogas. So this is the data about biogas from 2012 until 2018. Approximate the power generation for biogas in the year 2017 by using Lagrange interpolation and Newton's divided difference. In this project, we need to solve by using at least two different numerical techniques. For my part, I will provide a step-by-step explanation of Lagrange interpolations, quadratic approximations. So the question asks to calculate the power generation for biogas in the year 2017. 2017 is located at here. So for step 1, create a table and consider the 3 points. Start from 2015, 2016 and 2018. Step 2, applying the formula and we directly get the answer. Sum of all the value and the final answer is 160.8067. Referring the data of annual power generations for biogas in 2017, we can conclude that the final value is 160.8067 is approximately to 215.81.
Hi, I'm Nurin Izzati binti Arzumi, matrix number D810065. So I will present for method number 2, which is Newton's divided difference. Okay, for the first step, we need to create Newton's divided difference table. Okay, we must have our iteration, our x value, which is here, our y value, and our function of y. From this, we can capture that if there is 4 iteration, then our function must have 4. Next, we proceed to the next step, which is calculate the first Newton's divided difference. For f01 equals to f10 minus f00 over x1 minus x0, and we will get 21.855. For f11 equals to f20 minus f10 over x2 minus x1, and we get 12 over 07. For f21 equals to f30 minus f20 over x3 minus x2, and we get the answer 43.77. For f31 equals to f10 minus f30 over x4 minus x3, and we get the answer 58.66. After we got all the value, we need to write into the column so it's more easy for us to see the value. Now we proceed to the next step, which is find for the second Newton's divided difference. f02 equals to f11 minus f01 over x2 minus x0 equals to negative 3.2617. For f12 equals to f21 is 43.77 minus f11 over x3 minus x1, and we get the answer 15.85. For f22 equals to f31 minus f21 over x4 minus x2, and we got the answer 4.9633. For the third Newton's divided difference, which is f03 equals to f12 minus f02 over x3 minus x2, x3 minus x0 equals to 4.7779. For f13 equals to f22 minus f12 over x4 minus x1 equals to negative 2.7217. Okay, next we need to find the fourth Newton's divided difference, which is f04 equals to f13 minus f03 over x4 minus x0, and we got the answer negative 1.2499. Okay, after we got all the value, we need to write it in the column. Then we will proceed to the final step, which is find f 2017. Okay, we use the equation of Newton's divided difference, which is f00 plus f01 in bracket x minus x0 plus f02 in bracket x minus x0 x minus x1 plus f03 in bracket x minus x0 multiply x minus x1 multiply x minus x2, and plus f04 in bracket x minus x0 x minus x1 x minus x2 and x minus x3. So we will calculate it, and we got the answer 173.7495. Okay, now I will present for discussion of Newton's divided difference. Alright, firstly, we need to create a table with information on biogas, then calculate the first, second, third and fourth Newton divided differences using the provided formula. Next, add up the values from iteration 0 to determine the value of f 2017. Okay, and we got the final answer 173.7495. We saw that the manual calculation and software got the same results. And this method has a variety of benefits, such as It is useful for interpolation, and we learn about higher order differences using a difference table. Besides, differences at each stage may be easily measured by subtracting the previous value from its immediately succeeding value. Alright, that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nurul Farah Ain binti Nurhan. My matrix number is DA210088. So for my part, I'm going to present the software simulation. So the software that we choose is Maple software, and I'm going to present the Newton divided difference first. So for this Newton divided, we need to start with this student numerical analysis command. So by actually inserting this command, we can prompt the formula that is already exists within the software. Okay, so now we need to insert the data from X and also Y from the tabulated info we have in manual calculation. So after we insert it in the coordinate format, now we can go with P1. So P1 is for polynomial interpolation. So right after we run this one, it will actually give divided difference table P1 and its tabulated results. So with the final results negative 1.12499, we can check with the manual calculation either it is matched or not. Okay, so since we need to find the data on 2017, we insert function 2017 and it will calculate the result as 118.166. This is for Newton divided difference. So for Lanrage method, okay, so we need to start with data. So after we run with data, we can actually insert all of our info with X to Y. So we need to divide it not in coordinate format as we did in Newton difference. Okay, so after we run all of the info into the data system, then we can start with quadratic approximation. So by using quadratic approximation, it is to prompt the command inside the software. So now since we are searching for 2017, we can start with F 2017 and it will actually give all of this equation, and finally we will get the answer as 160.80667. This is for manual calculation proved by software application. Okay, so we can actually compare all of the answer here. Okay, that is for me. Thank you.
Now, next move on to the discussion of Lagrange interpolations. Calculate by using quadratic Lagrange interpolating polynomial. Consider only 3 points of the equations. Applying the formula for quadratic approximations, we observe that the final answer is equal to 160.8067. So the result of manual calculation and a Maple software are identical. This method is more efficient because it can be used to get the value even the parameters are not evenly spaced. In conclusion, we are able to understand more concepts about Lagrange interpolation and Newton divided difference to solve the real data that relate to electrical engineering. So first one, the Lagrange theorem summarizes well-known mathematical principles such as the concept that a line is uniquely defined by 2 points, that 3 points uniquely determine the graph of a quadratic polynomial, and so on. So the advantage of Lagrange interpolations is it can be used to get the function values even the parameters are not evenly spaced. Next, Newton's divided difference technique is a numerical process for interpolating a polynomial given a set of points. The advantage of Newton's divided difference are the additional data may be added to increase accuracy, and the preceding data point terms can be utilized again. So Newton's divided difference is better than the Lagrange interpolation because we got the final answer is equal to 173.7495, which is approximately to 215.81. Lastly, the result of the software simulation, which is Maple software that we got, are the same as the manual calculation that has been calculated. By getting the same answer, we can say that we are able to using of Maple software to prove the manual calculation is correct.